We're presenting before you our project Automatic Depression Level Analysis using audio-visual modality. Depression is a common mental disorder which is quite common in today's world, and it affects a person in a negative way, leading to anxiety and panic attacks. A lot of people are undergoing through this disorder. Thus, an early and automatic detection and recognition of the same is required. The scope of our project is an input video is being taken, which is being divided into two streams, audio and visual, and for both the streams, individual processing is done. And finally, regression is applied to get the final BDI value. The objective of our system is that every time going physically to a doctor is not possible as it is a very lengthy process. Thus, we have automated our system using ML techniques for through visual and vocal expressions.
In the literature survey, first paper we referred as 3D dimensional effect and depression recognition challenge. This is our dataset paper, which is AVEC 2014, audio visual emotion recognition. In this, all the details about the dataset is provided, like how the videos are recorded, what are the duration, and what is the procedure used for recording. And second paper we used is automatic depression scale prediction using facial expression dynamics and regression. In this, handcrafted features are extracted followed by FDHH. FDHH is a dynamic feature extraction method using pixels. Next slide. Third paper we referred as artificial intelligence system for automatic depression level analysis through visual and vocal expression. This paper is our base paper in which deep features are extracted using VGG and followed by which FDHH algorithm is applied for dynamic feature extraction, which is using feature vector, and MFCCs are extracted for audio features. This is our architecture diagram in which user will register and details get stored in the local database. The user will log in and provide a video, which is then segregated into two parts, visual and audio, which will give a single value prediction. By combining it, we will get a final prediction, and which will get displayed to user, and the user has a facility to see his previous reports through the history tab.
So the input to our system is a video, which is then bifurcated between audio and visual stream. Feature extraction is performed. For visual, VGG is used, and for audio, ZCR, MFCC, and ST is extracted. Dynamic feature extraction is done for both the fields. For visual, we have used FDHH, which will be explained in the later slides. Dimensionality reduction is performed for visual. Segment-wise linear regression is performed for audio, in which segment of 16 frames consisting of all the 18 features of audio is taken as a single segment, and all these segments are considered for regression. An aggregate of these BDI level is considered as in BDI level of audio. And for linear and for visual, linear regression is performed. Both these BDI levels are clubbed together using prediction level fusion. Next. This is our FDHH algorithm. The features which are extracted using VGG are taken, and then frame-wise difference is calculated between them, which is then compared with a particular threshold value. If that value and marked as 0 and 1, and later on they are divided between different patterns. In the previous FDHH, there was a condition which was getting neglected. In our FDHS algorithm, which we have modified, we are including that condition as well. We have used Python, and we are using PyCharm, and below are few of the libraries which we are using. Next. These are the details about the data set. There are 300 videos consisting of 6 seconds and 4 minutes till 4 minutes, and the BDI depression level is between 0 to 63, and they are then bifurcated between different levels. Next.
So this is the result of our approach. So these are the results in which, in terms of RMSE for audio modality, visual modality alone, and for the combined method. This is just the visual representation of the results which were depicted in the previous slide, in which orange is our predicted result and blue is the actual VDI level. We have developed a standalone system which was trained on 90% of the data, and these are the results achieved by our standalone system. So concluding the part, the results of our multimodal approach are better than most of the existing system. Our audio model alone shows remarkable results than existing audio systems, and the system which we have trained on 90% of the data set achieves good accuracy on the system. So we have submitted our paper in fourth international conference on smart computing informatics, and we have participated in CSI in a project competition in which we were the finalist. Here are some of the papers we have referred. Thank you.
Here is the demo of our system which we have proposed to automate the process of depression analysis. For the system, the user needs to give two videos as input. In first video, user needs to read a paragraph of about 200 words, and in second video, he needs to narrate a happy and a sad memory each. The user needs to register himself with the essential credentials, and if already a registered user, then he must log in. After registration, the user needs to log in again. The user needs to enter his email and name and upload two types of videos as mentioned earlier. The dataset which we have used is of AVAC 2014, in which total of 300 videos are provided containing 100 videos each, in which 50 freeform and 50 Northwind videos are there in training, development and test sets. We have used 90% of training data and 10% of data is given for testing. After the videos are uploaded, user needs to submit them, after which processing of video takes place, which leads to generation of frames as seen here. After this, processing of both the modalities is done individually and predictions from both the streams are combined to get a final value. Depression level of the person is displayed on the screen and report of the same is also generated, providing the name, age and depression level of the person. With the help of a history tab, the user will be able to view his previous two reports, and if the registered user is new, then the report he has is the current one. Accuracy of our system is calculated in terms of root mean square error and mean absolute error. RMSE of us is 7.8 and MAE is 5.2.